Welcome to this 2-minute video on deep learning with MicroStrategy in R, Part 2. In Part 1, we built a text classifier with the goal of predicting movie reviews for their positive and negative sentiment. We actually built a bunch of deep learning challenger models and let them compete to be the best. Let's call this the dense set, since all 32 challengers are based on one of 4 densely connected deep learning neural networks. We also varied 3 hyperparameters into 8 combinations of max length, max words, and train partition, holding out 20% or 10,000 reviews for our test set that will be used to pick the champion. Our dense set champion had an accuracy of just over 88%. We then deployed our champion deep learning model in our MicroStrategy dossier for on-the-fly scoring. In this video, let's answer the question, can we do better? Once again, I cracked open my favorite deep learning text and its chapter on using word embeddings instead of one-hot encoding. Word embeddings are actually orders of magnitude denser than using one-hot encoding to represent the words in our movie reviews. They are also called word vectors because similar words are closer than opposite words which are farther apart. Word embeddings are learned from data, and we'll build our own custom embeddings from our own movie review dataset. And just as there are pre-trained deep learning models for image recognition that can be found in today's phones and cameras, we'll also use pre-trained embeddings thanks to Stanford University's GLOVE project. And because embeddings are denser, our models can go deeper, and we can train our models using more words than before. So once again, let's start with the recipe from the book and define a new set of challengers using the Metric Creator tool. We'll change our text transformation from one-hot to embedding and label this set our embed set. Next, we paste in the model architecture from the book that uses an embedding layer and create 3 variations for a total of 4. We also varied 3 hyperparameters into 8 combinations of max words, embedding dimension, and train partition. Once again, we let the 32 challengers in this embed set compete. And the embed set champion model does have an improved accuracy of over 91%. We can visualize all 64 models we've created using our MicroStrategy dossier. And let's focus on this cluster with the best results. Our champion model uses pre-trained GLOVE word embeddings, outperforming our custom word embeddings. We should also note that these embed set models took well over an hour to train each, compared to just minutes for our dense set models. Can we do better? Tune in next time where we'll use a GPU to speed up the model training process.